Hi guys, my name is Mikayla, and for my project I was assigned surface area. This is a 7th or 8th grade level. I decided to do rectangular prisms just because using a cube is a little too easy and kids might not grasp the concept. And using a triangle or something is a little more advanced and difficult to teach. So I figured rectangular prism would be something that we could all work with, and it'll be easy to understand and a little easier to teach. Okay, so I'm gonna be starting with visual learners because that one's a little easier. So I found these super cool. They're from Dollar Tree. They're little foam cubes. They come with multiple different ones, and you can like break them apart if you want to make singular cubes and stuff like that. So I thought that'd be cool. I went ahead. These are different colors, but let's just imagine this is one whole cube. So this works really well because it has the individual cubes. So it's a little easier for a student to understand. So you can actually go through and count every single cube to find out your surface area. But for this example, I'm just going to start by showing measurements. Now these aren't actually in inches, but we're just going to go ahead and pretend that they are, just to make things easier. So I like this little guy right here. So we're going to use the biggest face as side A, the long face as side B, and the smaller face as side C. A rectangular prism has 6 faces. So side A, there's 2 of those. Side B, there's 2 of those. Side 3, there's 2 of those. We're going to start with side A here. We can go ahead and just count the cubes. So we have 1, 2, 3, 4, 5. That will count as our length on side A. So side A is here. Got 5, and we're just going to stick with inches and say that these are inches. 5 inches. And now for this little width side of face A, we have 1, 2, 3 cubes. So we're going to say 3 inches there. Now if we turn it this way, we've got side C, which we show right here, 2 cubes or 2 inches. So we've got 1, 2, 3, 4, 5 on this side, multiplied by 1, 2, 3 on this side, which you can see that here, that way, and that way, which is matching here. So there is a different formula, but I know when I was in junior high and when I was learning surface area, I had a really hard time because it confused me with all the like L times W, W times H times W. Those letters confuse me. So I kind of have my own formula, which is SA equals 2 times A, side A, plus 2 times B, side B, plus 2 times C, side C. So I'm going to use the letters for colors. Colors are a lot easier, especially for visual learners, to see where everything goes so it all adds up and makes sense. I definitely prefer colors when I'm being taught something. Okay, so we'll start with our first section. 2 times the product of A. So looking here and at our actual physical cubes, we can see 5 inches. 1, 2, 3, 4, 5. So that's one side or length, however you want to say it. So 2, 5 times, and then going this way down, same thing as this, because we're kind of looking at it at this angle. 1, 2, 3, same thing as this side, 3. Okay, and next we have B. I'm just going to go ahead and fill these out because it's pretty straightforward from here. Our next step is to multiply these. 5 times 3 is 15. 5 times 2 is 10. 3 times 2 is 6. We're gonna do this twice. Oh, inches. Sorry. Gotta stick with our inches. Okay, sorry, it got kind of sloppy there. And I forgot to rotate colors. That's okay. That's where our manipulatives come into place. So like, we can physically see, well, okay, Billy, the reason why we're doing 15 2 different times is because we have 2 sets of 15. So we can go ahead and just calculate that out. So we've got 30, 20, and 12. And I still forgot to change colors. But anyway, and then I used to get really confused about what squared and cubed and all those things meant. So I think the easiest way to explain it is, well, okay, Billy, if we're doing 15 double, don't we need to have the inches doubled? We need 2 15s, we need 2 sets of inches. So there's 1 inches and we'll turn them into 2. 1 inches and we'll turn them into 2. So on and so forth. Okay, and then we'll add all these up. We can do that off to the side. All right, 0, 2, 5, 6. So we've got surface area equals 62 inches. Kids still might not be like, whoa, 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 you just threw a bunch of numbers at me. So we can go ahead and count this out so that they actually understand why everything needs to be doubled and why I can only see 3 sides, but you're saying that there's 6. That's why we have our manipulatives. And this is really good for visual learners. I myself am a visual learner, so seeing it makes more sense. When someone's just telling me that, how do I believe you? How do I know that's true? So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Another 15 is 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus 30 is 40. Plus another 10 is 50. 51, 2, 3, 4, 5, 6. 56, 57, 58, 59, 60, 61, 62. You can physically see all of the squares. Now for this, it's a little confusing because there's 2 different colors, but you get the point. Okay, yep, that's it. Okay, so next we have our kinesthetic learners. These guys need to touch things, to use manipulatives, and actually see, I don't know how to explain this, see things used in real life. So one thing that I thought would be a good idea, and this is why I have this cute little picture, is gift wrapping. So I thought we could gift wrap a box. And so doing that, we will be using a net by wrapping the gift completely without any overlapping or anything, and using just every little piece of paper that we need without using too much. And using surface area is a perfect way to do that. So a lot of kids, and I myself, in high school and in junior high, they always ask, well, why do I need to know this? Well, this is another cool way to show them, like, look, you really will use this someday. You know, next time you're wrapping presents, you're going to wonder, how much gift wrap paper do I need? How many do I need to buy? They can actually measure out all their gifts and know how much they need to buy. So let's go ahead and do that over in the living room, and I'll show you guys how to trace it all out and cut it out and stuff, and then we'll come back to the writing board. Okay, now for our kinesthetic learners, we're doing the gift wrapping box. Come down over here where you can see a little better. Hopefully your vision is not too obstructed by everything. I had to use a couple weights to hold down my paper. So I got 1 tube of gift wrap. I already just cut a piece that I figure will fit. So we're gonna make a net out of this in order to completely wrap this gift without using any excess paper, using the least amount of paper that you have to. So I'm gonna start with my space A down, and we'll trace that. And try to stay as close to the box as possible. Now, just like in a net, when you open it, there's not gonna be any spaces, so you have to